During this video, we're going to talk about factoring trinomials. Today in class, we talked about a couple of steps, and our first step that we needed to work on is just to factor out a greatest common factor. And this means the greatest number that I can divide every term by. So in this case right here, I have a 2x cubed plus 6x squared minus 12x. And if you can see, if I break it down, that I have a 2 times x plus 2 times 3 times x minus 2 times 3 times 2 times x. So that just breaks it down into its prime factorization. So you can see that in every single term I have a 2 and I have an x. So I'm going to just highlight these. So I can pull those outside the parentheses. So I have a 2x in every term. I'm sorry, there should be another x there. So I have x squared that's left plus 3x that's left minus 3 times 2 is 6, and I have no x's left. So in this case, my greatest common factor is 2x, and then I'm left with the trinomial x squared plus 3x minus 6. So that's always our first step. Now you won't always be able to factor out something, but at least try. It will make your next work so much easier. So we have a few different scenarios. We have our first scenario where you can see that it's going to be the difference of perfect squares. And this scenario happens when you have two terms. And those two terms consist of like x squared as one of the terms, and then the difference, so there's a subtraction sign there. And then say for instance 9. And in this case, if I have x squared minus 9, if I'm going to factor it out, I'm going to have an x in each of my parentheses, sets of parentheses, and the signs are always opposite, plus and minus. So I know my perfect square of 1 is 1, so I don't put that in front of there. But my perfect square of 9, or the square root of 9, is 3. So I have a positive 3 and a negative 3. Now, you can always check these by FOILing. So I have first, x times x is x squared. I have inside or outside, which is negative 3x, and I have inside, which is positive 3x, and then I have last, which is negative 9. And then when I simplify that, I come up with my original, which is x squared minus 9. And that's always my goal, is for them to be equal to each other. I'm not changing anything. So let's review. If I have like y squared minus 16, difference of perfect squares, I know that I'm going to have two parentheses. I know I'm going to have my variable as my first term in each, like 1y, because the square root of 1 is 1. And I'm going to have a negative and a positive there. And then I just take the square root of 16, so it's y minus 4 and y plus 4. So if you look at number 2 here, it says y squared minus 64. Again, I have my variable in each of the parentheses. I have a negative and a positive, and I could change that around and have positive and negative like you see on the sheet up here, and it won't change anything. And then the square root of 64 is 8. Now, to go one step further and make it a little bit more complicated, if I had 4y squared minus 64, it would still be the difference of squares, because 4 has a perfect square of 2. So in this case, my first term in each parentheses would be 2y, and then I would have minus 8 plus 8. So, I'm sorry you couldn't see that, but there's the rest of that one. So here I have 4y squared minus 64, and I have parentheses, and 2y minus 8 times 2y plus 8. And if I FOIL that, it will come back to 4y squared minus 64. Okay, and then we have the second scenario is after you factor out your greatest common factor, you're left with three terms, which is called a trinomial. So I have three terms here. I have x squared plus 3x minus 6. And there's different ways that you can see it. So there's 4 different things that can happen here. It says check to see that all of your terms are in order, and in this case I'm going to put x squared plus 3x minus 6. So they are in order. There is a exponent of 2, exponent of 1, and then really an exponent of 0. There isn't any variable here. So then I'm going to look at my last, the sign of my last term. And in this case, it is negative. So if I look at my last term and it's negative, so I could highlight this right here. If the third term is negative, then the signs in the two binomials are one positive and one negative. So plus and negative. Okay, so right off the bat, that part's taken care of. Now, the next step says it does not matter what the other signs are. So I have plus and minus. So right now I'm not looking at the sign of my second term. But if the sign of my second term is negative, then my highest factor goes here. So in this case, I have 6, my 2 factors of 6, or my 4 factors of 6 are 1, 2, 3, and 6. So I know that it's going to equal, in this case, I might not even be able to do it. So in this case, I would probably want to use something called the perfect square, because none of these terms multiplied together that equals 6 can I add or subtract and equal 3x. So let's look at the example that they gave us up here on the board. So I have x squared minus 6x plus 9. So in this situation, I'm going to change it again. I have x squared minus 4x minus 12. In this situation, I have a negative in front of my last term. So we talked about it earlier. I'm going to have a plus and I'm going to have a minus. So then I look at this, and this one, my second term here is a negative. So I know my highest factor is going to be on this side of the problem. So I have a couple of different things. I have 1 times 12, I have 2 times 6, and I have 3 times 4. And one of them has to be negative and one of them has to be positive. Well, now I have to figure out how can I get negative 4 when I add these numbers. I know 1 plus 12 is 13, 12 plus 1 is 11, 1 minus 12 is negative 11, so that doesn't work. Then I go on and I say 2 minus 6 is negative 4. So 2 minus 6 is equal to negative 4, which is exactly what I want it to be. So I'm going to put the larger factor 6 here, and then I'm going to put the smaller factor 2 there. So then I factored out my trinomial x squared minus 4x minus 12. Let's look at a different scenario, and these are all on your little sheet here. Different scenario where we have a positive in front of the third term. And so in this case, I have x squared minus 6x plus 9. And in this case, it says if it's a positive, then look at the second term. And if both of the signs in the parentheses are whatever the second term sign is. So my second term sign is a negative. So in this case, both of my signs right here in the parentheses are going to be negative. And then I can move forward and I can say, okay, I have 1 times 9 and 3 times 3. So I have to figure out what numbers I can add or subtract together. In this case, subtract 2 negative numbers, or I'm going to combine 2 negative numbers. And negative 1 minus 9 is going to be negative 10, so that's not correct. But negative 3 minus 3 is going to be negative 6, which is exactly what we want our second term to be. So I'm going to do negative 3, and I have x. And whenever I FOIL it, it's going to be x squared, and then I have negative 3x
negative 3x, and then plus 9, and x squared minus 6x plus 9 is exactly what I want my trinomial to be. So another example is when I have x squared plus 6x plus 9, and I have x here in each of my first terms. So I look at my third term here, and I have a positive number. So I know that they're both going to be the same. And then, or a positive number here, and they're both going to be the same. So I have plus in both sides. So I look at my second term. And then again, it's going to be plus 3 and plus 3. So, and you would FOIL to check.